Doburia Niketan. Here we are discussing basic electrical engineering, and in which we are discussing chapter number 1, DC circuits. In this today's video lecture, we are going to discuss our next series, and that is delta star conversion. So let's discuss the what is delta and star connection. Up to now, we have discussed series and parallel connection. Here, we are going to discuss our next type of connection, that is delta connection and star connection. First of all, let me make you one thing clear over here. When we discuss series and parallel connection, that is known as a two-terminal connection. Why that is known as a two-terminal connection? Because when we form series or parallel connection, final number of terminals will be there 2. Here, what we are going to discuss is known as a three-terminal connection. So if we form delta or star, first of all, that is going to be formed in between three terminals. As an example, here we have three resistors as shown in this given diagram, which are connected in between three terminals A, B, and C, as shown in this given diagram. But if you arrange these three resistors in between these three terminals in form of a loop, as an example as shown in this diagram, from this A to B we had connected R1, B to C we had connected R2, and C to A we had connected R3. So here we have three resistors in between three terminals in form of a loop, that is known as a delta connection. Now, if you connect these three resistors in this manner, where we had connected a first terminal of all three resistors at a common point, let's say this is a common point, and second terminal of all these three resistors at this A, B, and C terminal. This will form a star connection. So basically, in star and delta connection, we are having three resistors on three terminals as shown in this diagram, which is forming a delta and star connection. Again, let me make one thing more clear. Here in delta connection, we have defined these three resistors by R1, R2, R3. In star connection, we have defined resistance as a RA, RB, and RC. And we had defined terminals as the same A, B, C. Now, in this theory, we are going to find out a method how we can convert delta into star connection. And for that, there should be a first condition: this delta connection and this star connection must be equivalent. In a simple language, both are having same values. What means same values means? That doesn't mean R1, R2, R3 having the same value means RA and RB and RC. But to form this circuit as equivalent, there should be various conditions over here. As an example, here if you measure the resistance between these two terminals A, B, same way if you measure the resistance in between these two terminals A, B, that should be same. Same way if you measure the resistance in between BC and O here BC, again that should be same. Same way if you measure resistance in between AC and AC, that should be again same. So if these conditions will be fulfilled, then and then only we can say that these are the equivalent circuits. And after that we can convert delta into star or star into delta. So again, let me repeat it. Value of the impedance will be the same if it is measured between any pair of AB, BC, or C pair of lines, irrespective of whether the delta connection is connected in between these two terminals or the star connection is connected in between those two terminals. So that was just in another words. So if you want to derive these conditions, how it will be derived? Let's start with the first one. First of all, let's consider first two terminals A and B, and let's measure the resistance between this A and B. And for that, first of all, let's consider A and B of delta connection. And when we consider this two terminal, we will consider that third is not connected to anywhere. So basically this C is open terminal over here, there is no other connection. And if we measure the resistance between A and B in this condition, so here in A and B, R1 is directly connected, and across this A and B it is R2 and R3 forming a series connection and which is in parallel with this R1. So basically equivalent resistance across this AB is going to be R1 in parallel with R2 plus R3 as mentioned over here. So this resistance RAB is going to be R1 parallel R2 plus R3. And if you find out the value of this, that is going to be multiplication of this 2 and again in division addition of this 2 that is given over here. In same way, if you measure resistance across AB in star connection which is given over here. So if this C is open, that means no current will flow through this C terminal. So we can neglect this RC resistor. In that condition, if you measure resistance between A and B, so in that condition, this RA and RB in series connection. That's why RAB is going to be RA plus RB. So, and as we are considering these are the equivalent circuits, that means this RAB and RAB must be same. If we compare these two values, means RA plus RB, which is derived over here, and another value of RAB, which is derived over here. So if we compare, so we are getting the first equation over here based on our first pair of terminals. Same way, you can consider another pair, and based on that, we can derive the another equation. Let's consider terminal B and C, and on that, if you derive the same equation over here, so that will provide RB plus C from the star connection. Same way, this if we measure resistance across BC in this delta connection, so that is going to be R2 into this R3 plus R1 divided by addition of all these three. So this was across B and C. Same way, we will consider third pair and we will measure the resistance across C and A. So let's start the third pair. So for third pair, we are getting the equation RC plus RA is equal to. Now, if you measure the resistance across over here, that is going to be R3 into R1 plus R2 as mentioned over here divided by addition of all three. So now we are having three equations which must be fulfilled to consider these are the equivalent circuit. And now we are going to convert delta connection into star connection. That means we are supposing that we are having this delta connection. That means we are assuming that we are having the value of R1, R2 and R3. We want to convert it into delta. That means we want to find out the value of this RA, RB and RC. Based on these three conditions, we will derive the RA, RB and RC. So let's start the derivation over here. And for that, we are going to add the all three equations 1, 2 and 3. So basically, on left hand side, we are getting 2 times two times RA, RB and RC. So basically, it will be 2 into multiplication in bracket RA plus RB plus RC. Same way, on right hand side, if you multiply these terms, as an example in equation 3, if you multiply these terms, so you will have R3 into R1, same way R3 into R2. Same way, if you multiply over here, so we will have a term R2 into R3, again R2 into R1. If you multiply first of all in all these three equations, and if you find out the common terms from this all three equations, so you will have a value as shown in this equation, and that is 2 times R1 R2 plus R2 R3 plus R3 R1 and divided by this base is same for all, that's why division base will be common R1 plus R2 plus R3. Now in this term we are having 2 over here and 2 over here, so this 2 and 2 will cancel out each other, so basically we are having equation RA plus RB plus RC is equal to this given term. And based on this term, if we simplify further, as an example, that was equation number 4. Now If we subtract the equation 1, 2 and 3 from equation 4 one by one, then we will have an equation as Ra is equal to R3 into R1 divided by addition of 3. Same way, next equation Rb, that is going to be R1 into R2 divided by addition of this 3, and same way this third equation. So basically these are the equation by which we can convert delta into star and find out the value of registers which are in star connection with Ra, Rb and Rc. Same way, if first of all consider that if in delta connection there are three resistors and if all are having same value, means R1 is equal to R2 plus R3 is equal to R, then what will be the value of Ra, Rb and Rc? So if you put the all values of these as R, we are getting the R into R divided by R plus R plus R. So basically that will provide R by 3. That means if in delta connection all three resistors having value 30, 30. So in star connection all resistors will have value R by 3, is 30 by 3, that is 10 ohm. So this was the delta to star connection. Again, now we want to convert star to delta. Now how it will be converted? For that, as we had derived the value of Ra, Rb and Rc, based on that we are going to find out the star to delta. If we are having the star and we want to convert it into delta, so what we can do over here? Now for that we can multiply the equation 5, 6 and if we can multiply the equation 6 and 7, and same way we can equation multiply the 7 and 5. If we multiply these equation like this way and lastly we add these multiplication as shown in this equation, we will have these value as mentioned in this equation, and that is going to be Ra into Rb plus Rb into Rc plus Rc into Ra, and same way if you multiply on the right hand side we are going to having the value as mentioned in this given equation. And now if you observe this given equation, here we have common term is R1 R2 R3, same way here R1 R2 R3, here R1 into R2 into R3. We can take this term as a common R1 R2 and R3, so you will have a remaining term as a R2 from over here, R3 from over here and R1 from over here, and bracket you will get R1 plus R2 plus R3. But in division we are getting the same term over here, so that will cancel out each other. So basically now we are having the value R1 into R2 into R3 divided by R1 plus R2 plus R3. So basically we are getting the equation of these term Ra into Rb plus Rb plus Rb into Rc plus Rc into Ra is equal to these terms. Now let's say if you want to find out the R1, 2 and 3. So here as an example, if you want to find out the R3, if you observe this equation and this if you separate this R3 term, if you separate this term R3, so we are having value R1 into 2 divided by R1 plus R2 plus R3, and this equation is nothing but a value of Ra which was derived previously. So basically this remaining term is defining Ra. So basically you can replace this term by Ra and you can put this term in division on left hand side. So basically we will have R3 is equal to this Ra into Rb plus Ra into Rc and again plus Rb into Rc divided by Ra. Similar way you can derive R1 and R2. So this was the star to delta connection. And same way as we had discussed in previous topic, delta to star. Now if in star connection all resistors are having same value is equal to R, then what will be the value of resistor which is in delta connection? So if we consider all are having value R, so if we put all values over here as R, so we are getting the 3R square divided by R, that is nothing but a 3R. That means as an example, if we have one delta sorry, if we are having a one star connection in which all register are having value is equal to 10 ohm, and if you convert into star, then in that star connection all register will have value 3 into r means 3 into 10 is equal to 30 ohm. So this was the delta to star and star to delta connection. Here first of all this is for delta to star, and same way this is for star to delta connection final equation. By using this equation you can directly convert delta to star or star to delta. Thank you for watching this video.